All right, thank you and everyone for joining the Internet of Value Foundation New York, episode 127. For all of those who get to listen to this information in the future, truly appreciate all the great minds and individuals who come in here every day and share this information and perspectives. and I hope everyone enjoys the space and information we speak about today. I'm going to go get some content posted up top, and having a weird issue with the bottom right. For some reason, there is no bubble there, but there is a little retweet button, I guess. Um, yeah, just a couple moments. I'm going to go grab some content and I'll start speaking away. Oh, welcome to the space, lady. I'm glad somebody joined. I was wondering for a second because it started weird for me on my other account if it was actually working. So thank you. Welcome to the space. Yeah, I'm just gonna grab some content in relation to the topics above today and go ahead and start speaking about it. And if anybody has any questions or thoughts, feel free to hit the request to come up. Unfortunately, at least I don't see a bubble at the bottom right, so nobody can write anything on the space itself. Or I guess you could go to the comment section of the post. But welcome, Viper and 808. Just give me 1 second. Just grabbing one video that I want to post up top. Perfect.
Yeah, normally I'm doing my running around right now, and I always miss these.
Oh, well, welcome to the space. And if you have any questions or any thoughts on any of the topics above, you're more than welcome to start off with asking. Were you able to hear me? Was I working there?
I was looking at it, and then I was thinking, yeah, I'm probably better off listening.
All right. Well, yeah. And just in case, like I said, if you have any thoughts or anything, feel free to just unmute or raise your hand, whatever you want. But so in relation to the video I posted above up top today, and we could do, I'll probably do a little quick chat because it's just a quick little summary. Some of the things that I wrote down that I found was interesting, and in particular, this the way he describes. Oop, sorry about that. Did I just? Are you able to hear me
Yeah,
still?
you rugged.
Sorry.
I can hear
Yeah.
you. Yeah, you rugged a
Yeah,
little bit.
and the way and when I say he being Neil Turok, which is a physicist, the way he describes this model in which uh, he has taken Einstein's theory of relativity and tried to uh, describe how the universe could with consistently adhering to the numerical properties of saying Einstein's theory of relativity and the numerical significance behind these symmetries, right? Be able to describe the Big Bang, right? And why the Big Bang actually has to exist for the universe to be the exact way it is, and from a mathematical proportions perspective. And he has a newer theory, right? Because in physics, physicists today, a lot of the big and more popular theories that are starting to, of course, become more popular, like string theory, which something that was like frowned upon in the 1960s, but a crass, a large majority of um, the physicists today actually believe, in particular, that the string theory might be a possibility of a way to numerically, you know, uh, describe all of these interactions on this very minute scale from a dimensional aspect that creates the very large aspect of general relativity. And there's of course there's a slew of couple different ideologies and things in physics. And what Neil has done is said, scrap all of that stuff, right? Because you start talking about 10 dimensions, 12 dimensions, 26 dimensions. I mean, this takes something like the Schrodinger's equation, right? Where there's an infinite amount of dimensions, technically, from proportionate amount of view. And so that doesn't make any sense, right? In some sense, right? Like, there's no benefit to using that to get any sort of structure of understanding anything that would mean anything to us in our realm of existing, right? I mean, what's the point of okay, describing infiniteness? However, what Neil has done is said, okay, take all this craziness, get rid of it. Let's try to create a proportionate properties in which the standard model of physics today, right, all of the particles that we know of today, the Higgs boson, fermions, these representations of quarks, which different bound together ups or downs create protons and neutrons, which with an electron creates an atom. And so taking all of these these things that we have today in physics, and the Higgs boson being the most recent discovery, um, and being able to just use these as a way to describe how the universe came about. And it's really elegant. I recommend, of course, everybody watches the video. I think it's like an hour and 45 minutes, so it is definitely a longer one. And he has plenty of things out, but this is a particular interview that was just recently done. I thought was excellent. And it's his mathematical theory is not yet published and live, but from what he was speaking about in the video and where his philosophy is leading, I really thought it made a lot of sense. It wasn't something that I've actually really thought about too much from a physics standpoint of particles, and thinking about something I've said before, and it's actually a quote from Oppenheimer, right? The more that we dig, right, the more that we crack open the shells of these masses of energy, the more different types of particles we will find, the more different types of fermions or maybe a gravity a particle, right? Something to just to furthermore help us understand why matter is what it is, and gravity is exactly the force in nature. That reason to keep searching, deeper and deeper and deeper for these more minute particles, which, even when we talk about something like an electron, I mean, there's no physical electron that we're actually talking about. In substance, we're actually talking about a mass of energy in relation to other masses of energy. And it's I think it's profound, because if what he is talking about is mathematically proven, and in the video, he talks about some of the things that will be implications that could be furthermore help us understand um, these masses of energy are actually dark energy, dark matter, which was one of the last things that was just talked about. It could further help us understand, the vacuum energy state. This is zero state of energy, in which we kind of think of the universe the majority of the time as having no energy in these vacuum states, yet quantum mechanically filled with an infinite proportion of energy. Um, this will help us lead to the possibility of physical things like wormholes. I truly believe, and yeah, it's really cool from a mathematical standpoint, not just a technological standpoint, where we have things like AI and all of these other tool sets that are able to kind of combine things from an interoperable standpoint and make it relative to ourselves, but from a numerical standpoint, something like this that's coming close to possibly being proven derived. I spoke a lot, but feel free though anybody to come up if you guys have any questions or thoughts on anything I've spoken about so far. Welcome, Vet Chris, Crypto Queen, Kelly, Freeman, Chef, OC, Fridge, Ben. Feel free. If anybody also wants to check out the other link that I posted up top, so This is just DESI, which is a neutrino tester in Antarctica, right? These neutrino shells that they've been testing in the ground for a long time, and now there's actually the version 2 of DESI, which is coming out, which is going to furthermore help increase the ability to kind of test this astroparticle physics part of this, what we think of this vacuum state of energy possibly existing. And so some of the things though, um, that I took from this, because there's a lot of mathematical properties. When you listen to him speak, you can totally get lost in it because he's highly intelligent and really gets to the point. And sometimes it's really really simple, but there are, the mathematical properties behind it is still very complex. Though, so some of the interesting things where he talks about the forces in relation to mass and particles. And so, today, um, from the amount of generations of particles that we see, it fits exactly into the theory in which he is actually calling the dual universe theory, or the mirror universe, in which our universe, or what everything we're actually viewing when we look back at the universe, is in relation a mirror of uh, everything else. And so, this kind of dual-sided universe possibility, um, and why. I'm probably not going to do the best job at describing it, and so that's why probably everybody should watch the video above, because this is still a newer theory, especially um, uh, just in the whole thought of the physics community and stuff. But so when thinking about things like gravitational waves, and trying to um, map out the Big Bang, right, or the beginning of the universe, which, you think about this very hot, soupy mass, something like 10 to the 30th power of electron volts of energy, right? Just something just so unfathomable amount of heat and energy. And so, at the beginning of the universe, you would think that the muons and the gluons would theoretically be the same temperature, the same relative means as gravitational waves would be, right? They would all be essentially in kin. And so, when thinking about trying to look back at the old universe, and um, the massless states of particles in which, from a photon's perspective, from a massless particle perspective, uh, when it gets read by, say, a detector, or it interacts with something like the Earth, or reaches its state of destination in which it is, the wave function collapses, right, and it is realized, that photon, or that state of massless particle, uh, never perceived any difference in state from beginning of universe to state of realization of wave function collapsing. And so, trying to measure the scale in which these massless particles are interacting with, say, a detector, we can start to try and measure the states in which interactions would have occurred on in the Big Bang. And so, um, one of the things that he had spoken about was, there are gravitational wave detectors we have today, right? DESI being one of the finest ones that we have going on in Antarctica for neutrino tests. And even with that, we need detectors that are 1 billion times more sensitive than the tech that we have today to, say, be able to measure the scale in which this Planck scale that the universe would have been evolving on. Um, and so, why does that matter, right? Well, so if we can understand the pre evolutionary state in which produced the states in which we see today, we can further then make interpretations on, relations of quantum mechanics and of us interacting with these states in a meaningful way. And so, this is, it always comes back to me, this really significance that all of these evolutionary technologies of this mathematical properties in which we have been able to, as a species, come from one place and evolve to the next is in proportion to the technologies and the tools that we use. And so these things being extremely important when, thinking about our future as a species and the things that we'll be able to do from an actual physical state, right? The things that we'll be able to change. And oh, sorry, I'm muted there. 808 though, if you would like to jump in, man, welcome up. And anybody in the audience, please feel free to come up. I've spoken too much so far. Although I can keep going on. I just, intermission. If you have any thoughts or anything on anything I've spoken about.
Like talking about black holes and stuff just reminds me of when some of the telescopes first kind of was able to capture some of it from on top of Mauna Kea, and the naming of them comes from our history, our my ancestry called means embellished dark source of an ending creation, which is unreal because I always share about the Kumulipo, what it talks about the creation from it's a creation chant that my ancestors had passed down for thousands and thousands of years, where it talks about a lot of these things, black holes. Uh, it's so unreal because when we talk about these things, we're using technology nowadays to kind of bring forth a lot of that knowledge and innovate off of to kind of better provide things that we use today. Um, and that's just a thought I was getting into because of just recently a couple instruments from the Canada, France, and Hawaii telescope was also just given a name, which is a spiral spectrograph and a ESPA DONS observes, which they observe stars and colors of light emitting from these stars, which the name these students were able to give that telescopes their names, which is unreal because even that within its names, I shared what it meant. It really describes how we're because it came about when we were talking with that flat Earth guy in that camera, and I shared a photo of a picture I took when I was on Haleakala observing the celestial bodies, where there's a phenomena that happens when light breaks the horizon before even the sun does, which is still plasma, it's still energy, which we are able to capture and understand, which it always astonishes me because our ancestors even were able to capture and observe and record, even given its name, Venao Keao, which means the two different meanings within that word speaks of its earliest glow of light, which is Vena, and then Ao, which it represents the different colors and the different energies emitted from it. And from within these two telescopes, it really breaks it down to the quantum level of them, of these different colors emitting from these stars, which has so much data that can be so profound when doing certain studies to understand how these things are connected, especially when you put into computer science and technology, robotics, and all these other things that are built within to these infrastructural ecosystems we have. That's all this issue. I love it.
Yeah, I really appreciate you taking me there. 808, you gave me a second to put some water in my cup to make some tea. And so, aloha, brother. And I couldn't agree more, man. And going to that, right, like the start of you mentioned, right, like dark energy and dark matter, and like that being something like in relative nature of there's all this darkness up there, right? And so there's some sort of polarity in in relation to the magnetic difference of whatever these other particles are, being light particles, right, or mass particles. And so one of the things that Neil actually has in this model is through the interaction of generations of evolution of fields of interaction. And I'm kind of butchering this because he describes how he gets to the description of 72 magnetic fields existing through interaction in the universe to create galaxies in proportion to the exact circumference and unity in which that we see space to be at. And with this, the three generations of particles of neutrinos being these, call them left-handed particles of neutrinos, which be somewhat massful, the ones that we kind of observe um, in relation to particle physics today. And so, in this theory of this mirror universe, or this how he coined it, a dual universe, uh, the mathematical proportions in which relation to the entanglement of the separation between left and right of these neutrinos would be existing in this mirror universe, and uh, um, proportionate to their weight would possibly give the understanding to why we see or think of dark matter or dark energy. He describes one of these particles possibly being the particle in which that is dark energy. And so that um, really interesting, right? Because if something like that were to be understood from a mathematical property, I wonder the possibilities of the technology that we'd be able to discover. That's just really interesting, right? And that's, talking about wormholes and the quantization of matter in relation to entanglement and creating opposing forces from magnetic connections, which allow the proportionate amount of information to travel faster than energy in itself can theoretically move. I think it's super cool. Chris, welcome, man.
It is
Oh,
awesome.
sorry. Go ahead, Adway.
Oh no, it is awesome because a lot of these things that have been studying actually brings back a lot of brings me back to history. Like I was just explaining with pole. Pole is not just a word, but it also carries a deep significance within the celestial bodies and natural phenomena. It really does refer to darkness, our night, our absence of the light symbolizes the realm, creation, all of these things. And within the Kumilipo, the chants pole represents primordial darkness from which life emerges. That one sentence speaks of this energy or this thing that was discovered just recently, from a lot of more in depth, I would say, by this substance created by dark matter and such and such. It is crazy because these black holes or regions of space and time where gravity is strong, that nothing, not even light, can escape from them. Cosmic darkness, which pole represents all of that. Now, this is knowledge that's very old, and like I said, it's been passed down, and now we have uh, newer technology proving that these things to be true, which is unreal. Because if you even look through other cultures out there that had more in-depth and observation of the celestial bodies, they have similarities to a lot of the things we are seeing and talking about today, which a lot of the technology now is breaking it down to a much in-depth level to where we can apply it in a different way to how we use it and construct our technology. Look at how we construct computer systems, supercomputers, how things communicate, how we understand to try to communicate with each other on a different level, to even the natural understanding of plants and things around us that has this deeper connection that actually gives us a good healthy ecosystem that allows our bodies to fight against certain things that comes our way, which is even brings about it even at a much more deeper meaning when you start to go further into a lot of these studies, because you don't just go further into studying about these newer technology. It actually brings you back into history as well, and you see the interconnectedness from how understanding historical knowledge can better the foundation for further innovation from what we're learning today, which is awesome.
I could not agree more. Welcome up, though, Chris. Feel free to jump in if you want, man. Any thoughts on anything we've spoken about so far, or anything I said?
I would, I'd love to be able to speak intelligently about what you're talking about, but I'll probably just come off like a dumbass. So I just enjoy listening to it all. It's interesting stuff. Um, I just come up to say hi.
Well, thank you very much, man. And listen, this is, for me, this is a very a much newer theory, right? Typically, when you start talking about particle physics with physicists and in relation to the Big Bang and how the universe is sculpted the way it is, right? From a from a not a proportionate stance of necessarily how we meaningfully interact with it, but how did we get to this evolutionary point? And in most relations, it's right. We A lot of popularity today is string theory and talking about multi-dimensional states, and through these interactions, created these entropy created these larger states in which that we actually observe as observers and perceive to see. And of course, in this model, that still exist as there's electrons and protons and neutrons, and the standard model still persists. And so these masses are still definitely described as insignificant in meaningful viewership, observatory ways for us as humans, at least at this moment in time. Um, but just this simplistic approach where you're not having to create all of these extra dimensional states that we're not able to prove exist. You don't take things like just saying, well, there must be different types of fermions to create different masses of states, and then in the relation to this is dark energy and dark matter, or trying to kind of put things where maybe it doesn't necessarily make the most sense. I think when he the way he described it, it really was very simple, and it uses everything that we have knowledge of today, everything that's been able to be proven physically in a lab, like bosons and fermions, right? And think about the Large Hadron Collider, where we've been able to measure different measurements of masses through high energy propulsion, and the smashing of this energy, right, releasing all of the energy, and sensors trying to absorb it in a high intensity rate. And of course, even the most recent tests, from like the Large Hadron Collider, which is the most powerful test that have been done so far using lead ions. Um, Even that information takes like a decade to really go through and be able to use it for some meaningful way. AI is helping tremendously in that kind of field, but still, there is just a petabytes worth of information that has to be numerically put together to make some sort of understandable way from it. But if you look at like the 1970s, where there was a lot of theorized particles that existed even deeper than bosons, and all of these different types of particles, the deeper we would search, we would find more particles. And not saying that that's not still the case, but I think the way he described it was like we don't really have to you know keep trying to put things where they may not necessarily fit. He's like, we may have done a great amount of research so far, this evolutionary state that we've gotten to so far, and we just need to build better technologies, sensors for the most part, right? These quantum technologies that we're developing on nanoscales, which are able to communicate these very minute electromagnetic frequencies in relation to themselves, the information that's being transferred through them, and the sensory ship of being able to interact with all of the other relations of electromagnetic frequencies. Um, I think we've gotten to a really great point where we have so much information, and I think with the possibility of um, maybe proving some of it to be substantial in this means. It could be used to then describe further things like the equations he may have to further help describe Einstein's equations used in wormholes and black holes. And then this could further lead to us being able to create some sort of public magnetic, field in which we could have wormholes, whether it be a ship or, uh, existing physically in front of us. I think it's cool to think about. 808, please jump in.
You know, you said a sentence I probably can't say again at the moment. But you said a sentence that is very interesting, because I have a neighbor that I rarely see, but it's because we were just talking about how advanced we are with having the ability to be able to create things on a level where it can do stuff, but we don't have the hardware powerful enough to do the job, or to be able to support the job in a sense. But that has been catching up, like how you said. I've got into it with Richard about solar power and batteries, which I do agree with him. Battery and solar power is a big issue, but it doesn't diminish the use of solar power. But even with battery packs, I just was talking with my neighbor about this the other day, how advanced um, that that is getting, especially with not using precious metals in a sense. A lot of studies going to graphene and other natural ways of to create things that could be able to be more powerful than what we're using today, and that can provide a longer holding of energy. Like right now with even just Elon's one, the Tesla batteries, like only like 10 days or something like that. There's people that and companies out there that has and created battery packs that can last for months, which is something very powerful, which a lot of the talks we talk about with a lot of these studies we do, talk about in here. I shouldn't say we do, but a lot of these studies help build these things and help understand and construct a lot of these systems to help maintain a lot of these energies, to help provide things that we use today. Especially, which is interesting because we've been talking about microgrids and macro grids, and how a lot of these older systems are realizing how powerful peer-to-peer is, how powerful is when you go back to like the community level, when you have the structure and the infrastructure at that level strong, and it's weakened at the moment, and we see that even within our own communities on every level, how weak we are as a community. Togetherness ain't even there. And when we get back to that thought process of being able to do that, I'm saying, use an example as solar power. We have companies that take advantage of others, where they're selling your excess energy that they said they're selling back to the grid, or to your neighbor, or they're taking the fees from that. Where in fact, if they're actually done what they're doing, that they said they're doing, it would actually make it cheaper for your neighbor to be able to provide energy, or even to get energy. But with certain systems, like how we see today, we have the technology and the hardware to provide a more better, transparent, and efficient system for us as a community, which even the macro grid and the energy uh, companies understand how powerful it is when they go back to microgrids, and how strong it is, because they can't handle the infrastructure by themselves because of the mismanagement over the years, and that's just fact. And thus a lot of this technology helps provide a lot of that infrastructure, which we're seeing going back to rebuilding of infrastructures, not just with the energy sector, all over. Look, even with the finance side, we see battles with the rebuilding of the financial infrastructure to supply chain infrastructure, which is crazy because we talk about a lot of these different technologies that interact with each other that help provide a lot of these means for innovation. So wild.
So I posted two more things up top, and this is something I saw in an article. Of course, I posted it from Brian from his page, but it was an article about quantum teleportation demonstrated, and so they used a qubit to essentially transport this information, and over a distance, of course, still using fiber optics. As a means of the electrical current. But yeah, nonetheless, this we are getting so close to these mathematical properties, not only being able to be proven in these virtual settings, but I think very close to a physical setting of where we'll be able to take something so large as an apple, right? Because You think about from a qubit perspective, when we're sending a bit of information or doing a numerical properties on a virtual setting in a test, and we're trying to transfer information through means of entanglement. You know, how in a resonance of complexity, right? How complex, and of course being very complex, but how complex is that comparably to things like the rearrangements of atoms that make up molecules that then make up something like a fruit or an apple, or even then take it to a complexity, right, of an animal or something like this. And so, I mean, the furthermore exponential complexity gets, the more intense it would obviously be to create a technology that would be able to uh, sustain these physical states of change, these numerical properties as we're speaking about them, and for it to be possible. But I think we're really close to that being a possibility, where the atoms itself will be able to be mathematically calculated, rearranged, and information be entangled. Anybody else have any thoughts on that, or this?
We're talking about quantum entanglement, yeah. Which is, I love it because even studies with the moon and tides helped with a lot of uh, our understanding of natural phenomena, which is quantum entanglement, yeah, with the moon and celestial bodies, with the ebbs and flows of our natural phenomena of tides, waves, and even the wind and all of that. And a lot of these studies of being able to map these celestial bodies help us create oceanography and climate monitoring, different technologies and software and algorithms, mathematical equations to help even do that at a minute level, to even more robust understanding of lunar explorations. And it's very, I love it. I love these talks. I love your spaces because even space-based quantum experimentations has been built upon a lot of history, ancestral knowledge, and knowledge that we are discovering today, even to more recent, about quantum entanglement, lunar and tidal studies, to even earthquakes and volcano activity and magnetism that comes out of there, which a lot of these are at the most minute level energies and different types of energies, which we are understanding more and more each time we study and dive deeper into it, to kind of better understand how these things are portrayed and about, and how we can harness them. And some ways we kind of went off the rocker and went a wrong way about it. That's just my opinion with studying a lot of this from historical till now. And now we're going back to how they're using a lot of history from indigenous knowledge from mo'olelos. Like, I always share with studies with the volcano guys in Big Island, where they're trying to discover these pockets of how Kilauea was created. And from their studies and their algorithms, they couldn't find these spots, even though that's what their technology was telling them. But then when they got back into using and going back into a lot of the mo'olelos from my ancestors, that was able to observe the creation of Kilauea over 400 years of observation, they were able to study and write down in these lines, which pinpointed the exact places where these studies were trying to find in these volcanologists. And they gave a very big paper about it, and very portrayed how important it is to understand not just using a lot of these newer technology, but understanding, having to grasp and understand a lot of the knowledge that was passed down through these different cultures, and not to interpret them because of our own knowledge kind of blanketed our minds to kind of understand them. Like how I was trying to explain, when we're trying to understand just even each other, we have a hard time trying to combat our own perception of that person, because we always perceive somebody before we even kind of meet them, kind of thing. And we're unaware of it. It's something that we always do regardless. And and kind of understanding that kind of makes a person better at receiving and understanding how to communicate better within any system, which is interesting because when you come down to even that level of even affecting your subconscious mind to better provide a foundation for even you yourself to accept things is even on a quantum level of understanding ourselves, which is wild, crazy stuff. That goes back to even how you shared something. Was it you or was it Shellfish that shared something about depression in our brain? And I remember I was sharing at one point we were strong enough as a human being to kind of dig deep down into ourselves and break that walls to reheal that synapse, that those connections that was broken and blocked by our significant impact that happened in our physical life, that kind of affected our subconscious minds, that pushed us past that to even just block that out the way. At one point we were strong as humans to even do that ourselves. Nowadays we use other means to kind of help that, but it's still yet not really helping, because even now we realize the synthetic way of trying to reheal ourselves even at that point is unsustainable if you can't break it at the most minute level, which is deep within ourselves as well, which is crazy because even at that, understanding the connections from all these different things not only makes us as a better person for ourselves but also our community around us.
Yes, I and today, for sure, like the sociological means, I think as a greater part definitely doesn't the incentive doesn't the incentive that's represented doesn't necessarily incentivize the community base. It incentivizes the singular base, right? And so I totally agree with you there, 808. Um, and that's I feel like that's a part of evolution as well in itself. Thinking of us as a whole, as a collective, from an intelligence standpoint or an intellect, logic, right? Um,
You know what I mean? It's like there's a lot of walls and barriers that's built upon ourselves already. But once we understand that a lot of the things that we do every day is connected, um, and breaking that one wall down already allows you to just grasp even more, to understand how these things are connected, or even just pushes you to even want to know more, because everything we do is connected. Like I like to share surfing. I don't just surf for fun. It's one of the best ways to exercise and keep healthy, um, in your everyday life. Even I use surfing to even I go diving at the same time I go surfing. There's a lot of things that we do every day that does help out on so many levels. Everything is connected, whether we're talking right now in this spaces, learning about blockchain, using newer technology, making things separated already is building walls to kind of block certain things away from each other. And while you block that, you're already giving yourself not a favorable position. You know what I mean? So you're already giving your subconscious mind a belief to block certain things where there's these things that shouldn't be blocked. That's what I'm just getting at.
yes, the underlying bias, for sure. And unless you perceive the awareness of this underlying bias, you don't perceive it and you are biased. And that just be the formula. So for sure, I couldn't agree more. I couldn't agree more. And I think, um, not to try and bring everything in relation to the topic that at least we were speaking of before, but I do think that like things like AI and the symmetries of understanding our actions in relation to being able to describe them in symbolic representations, mathematical proportions, I think also gives us a great chance to have like the collective, understand their actions and therefore the repercussions and the reactions of those actions and the complexity therefore on. It leads me to one thought actually too, in relation to the topic above, completely statistical mechanics, right? And so, you know, if um, if Neil's theory is able to be proven physically to be accurate in the next couple months, years, right? And we're able to then build off of kind of this next iteration of Einstein's theory of relativity. Um, I totally think that from a statistical mechanics standpoint and thinking about thermodynamics, this also plays a huge role in the understanding of proportions of particles and states of energy um, in distribution systems, right? Thermodynamics, so thinking about rockets and nuclear fusion. This is all of this kind of plays a huge role into this. Of course, we wouldn't have nuclear fusion today if it wasn't for the Einstein equations that led to the Oppenheimer equations, the understanding of you could take certain things out of masses of energy to increase proportion of velocity of reaction, right? And so, yeah, like all of these highly significant um, um, mathematical equations that we'd maybe not really think about in every day. I think we're coming really close to seeing the next iteration, possibly, with just all of these so smart scientists of our generation, the Neils of the world, and your Wolframs, and there's just so many people who are working so hard on this technology where we're at this point in time, and then to think about the internet and the internet of value, where we're going to be able to take all of this information and it exists in the form of value. Of course, it is all valuable to all of us intrinsically, but we'll be able to extrinsically utilize it in so many different physical things. And I think that's where it all leads. It's what it's all about. It's just our evolutionary process and state of this interoperable system in which we call the matrix of the universe. And with that, if anybody has any closing statements or thoughts, please feel free to bring them up if you guys want to hit the request, or if not, I'm going to close it up in like 2 minutes. So feel free, Ada, if you want to
There
start it
was
up.
there was something to close before I leave. You said something that's true. There's a lot of studies, a lot of fragmented studies, different studies that help build towards actually the same goal. And it's fragmented. I'm not saying it in a bad way. It's just hardware is not there to kind of be able to interplay them together to make them be able to innovate even further, create a stronger foundation than what we already have. But like I was expressing and explaining with the battery technology and how that has advanced extremely well and extremely fast. Technology itself, which we seen within the past 5 years or 5 even 10 years ago, from five to now, has extremely innovated and gotten better, and it is going to get better even further we go into the future. And it's interesting because as we are able to be more interoperable between a lot of these different fragmented studies and ecosystem and knowledges, like these different libraries and APIs and all of these different things, if you think about it that way, to even blockchain, all these different blockchain ecosystems, we even see the importance of interoperability and communication between them and those ecosystems, and we see it at that level innovating and becoming better, which is wild because once a lot of these things at that hardware level become better, it's going to be able to provide even more in-depth studies, more in-depth foundations for us to even build even better things to allow us to even further innovate or create even more things. Us as human beings, regardless of demographic or wherever we live, we're very smart motherfuckers, and we innovated so much to even till today. But we're our own enemies as well, so if we even got that. But still, we with a lot of the things we have and the importance of interoperability and the communication between these different hardware technologies has been getting better. We'll see a drastic change with a lot of things we do every day, which we do already. It's funny. But yeah, take care everybody.
Thank you very much, 808, and I couldn't agree more. It's we talk a lot about the future and technology. We kind of usually lead to that finishing end point where where we really talking about where we're at and where we're about to be, and it's great to see it. And I just can't emphasize enough that it wouldn't be if it wasn't for all of us going through these evolutionary steps and this learning that all of us do as a species to get us to where we are today. But Nerdy X Man, you came up right at the end. Please feel free if you have a comment or thought or anything, and I'll close up after.
Yeah, sorry for coming at the end, but just real quick, from what I found, from my own research and stuff, is that everything is moving as a service, and what's going to happen is that we're going to move more towards the green energy transition. People might think that it's just like, solar panels and fans or whatever, but that's not really what's happening. What's really happening is that we're going to move towards like thorium based, which is more like SMRs, like small nuclear reactors and stuff like that. And we're going to move towards, so like what Energy Web is doing, we'll probably move to a system where it's like decentralized energy grids. And if a grid in each, let's just say, district or area or region, whatever, would have a smaller nuclear reactor per that region. And what that does is it makes electricity cheaper. It makes cost of living cheaper, so people will have more funds and more time to do stuff for themselves.
I couldn't agree
Also,
more. SMRs and modular reactors are going to be where it's at for the next 25 years, especially when we think about third world countries where, you could
yeah,
have a factory bit modular reactor that could be put inside of a town that could fuel that town's growth, right? Because they get power and energy and it's
exactly.
abundant.
And so, like, the main problem with the whole green transition and the whole thing is that we don't have the infrastructure to even think about that. So
Yeah,
for
and
for
I
for
completely agree with you. I have to close up. I'm sorry,
oh,
nerdy,
sorry.
but it's a
Oh,
great topic, and I will keep it in my mind. Maybe we'll host
um
next space. We'll talk about.
Well, next one we go talk about this because I have a lot of information on this as
I'm
Yeah,
well with
yeah,
like
it's right.
aggregate
It's like it's
stuff.
a whole topic in itself for sure. And yeah, let's do it next week. We'll talk about energy fusion, the grid, what we think about it, where it should go. Right, all these new technologies that are being developed all over the world, or we could see all
Yeah.
the grids that are being developed and how they are. And yeah, if you're here Monday, 4 p.m.
Sounds good.
Eastern Standard Time, Nerdy X, I will be hosting that space as long as I can make it, of course.
Sorry.
But I hope everybody has a great rest of the night, great weekend this week, and I'll see everybody in spaces. And I love you guys. Space wouldn't be what it was if it wasn't for you guys.
Bye.